All the code and references in this video will be in the descriptions, and feel free to check it out. In this video, I'm going to first go over a high-level diagram of what I'm trying to do, and then I'll go into detail of how to do this using a tutorial. Okay, so currently in my project, I have a endpoint called scrape. So when this endpoint gets triggered, it's going to scrape Indeed, and then it's going to store that data in the database. Then the front-end UI is going to have another endpoint that triggers fetch endpoint, which will get the data from the database and then also return that back to the UI. The issue that I ran into with this approach is that scrape takes a long time. Therefore, the web server I'm using, nginx, it times out when I do call this endpoint, and that makes sense since scraping website takes a while, especially if I'm scraping 10, 20, 30 pages. So what I'm going to do is I'm going to use the RabbitMQ and Celery to try to deploy the task onto a queue, and then the consumer will consume that queue. So when the request comes in, my API is going to pass that function that scrapes the website to a queue using Celery, and then at the same time, when Celery sees a task in the queue, the consumer is going to start consuming the task. Once Celery finishes consuming the task, then it's going to store that data, which is the scraped data, into the database. And at the same time, it's going to trigger another API call or another function that stores the result data into the database. In this approach, the initial scraping API doesn't have to wait for scraping to finish before it returns a response. Something I noticed about this approach is when I try to deploy this onto the cloud, which is Oracle Cloud, I'm currently using the free version of it. And I noticed that whenever task is running, the memory usage is spiking up. It causes my VM to not respond. And when it doesn't respond, my VM just hangs. In order to fix it, I had to reboot the machine, which is not good. So I need to try to figure out why this is causing a memory issue and try to see if I can maybe try to optimize the memory usage when I do this task. Now I'm going to go into a small tutorial on showing you how to set this up using Docker and Docker-compose. So you want to start by downloading the base project from the project link provided in the description. Once you have that downloaded, you want to go into the start folder. Within the start folder, it's a simple Django REST API project. And within scraper folder, if you go to view.py, you'll notice that there is a class-based API view, and it has two functions. One is a GET request, another is a POST request. In the GET request, we are getting all the posts from our database and return that. In the POST request, we basically are trying to simulate a web scraping process by delaying the function call by 5 seconds, and then we will store that data into our database. So in this POST function, if you have a long-running task, for example, web scraping, that takes, for example, 10 minutes, then that means you're not going to get a response back after web scraping is done. And in this case, nginx by default will just time out. And what we're going to do is move the web scraping logic into a different function so that that function could get deployed to a queue, and that queue will get consumed by Celery. And that's how we're going to resolve the nginx timeout error, since it doesn't have to wait for web scraping to finish. Okay, so first you want to create a Python virtual environment. You can do that by running python 3 -m venv. Then you want to run pip install -r requirements.txt. Before that, you want to make sure you source it. You want to source the environment to activate it. And then run pip install -r requirements.txt. After that, you can run pip install Celery and also pip install SQL Alchemy, since Celery depends on SQL Alchemy. Okay, so now you have all the necessary packages installed. What you can do next is we're going to follow the documentation from the official Celery website and set our project that way. First, you want to go to core folder and create a new file called Celery. .py, and this is basically going to be the file that has all the salary configurations in it. Okay, first you want to import salary from salary, and then you want to set the environment variable called Django settings module, and you want to point that to our settings.py. And after that, you want to create a salary instance, and that's going to be our salary application instance, and I give it a name scraper. After that, we will load the Django settings into our salary app, and at the same time we have this namespace setting here set to salary. So this means that anytime that we create salary related settings, we need to prefix salary in settings.py to let the salary app know that the setting is specifically for the salary app. And this auto discover tasks automatically discover tasks within your Django apps. And one more thing that we need to do is in the init.py file, we need to include this so that we can make sure the app always imports every time Django starts. One more thing to mention is that when you create the salary object, usually you want to enter the broker URL and the result backend. But since we're importing settings from the settings.py from Django, we can actually set these two variables within the Django settings.py file. So you want to head over to settings.py, scroll all the way down. Then in here, maybe you can have a comment saying salary settings. So this is the broker URL, and it's currently pointing to our localhost RabbitMQ. The backend is just pointing to a simple SQLite 3 database. Once you have the settings ready, then you can go to scraper directory and create a new file. Call it tasks.py. Tasks.py is basically going to be the file that contains the long-running tasks. And in my case, it's going to be the web scraping logic that we're going to get from post endpoint. So first, we need to import the necessary libraries. Shared task is going to be the decorator that we're going to use to deploy the task to the queue. And then, that's the decorator. And then we'll define a function called scraping task, which takes in two parameters, title and location. And we'll print scraping in process and delay it for 5 seconds. This is going to simulate the web scraping process. And once the 5 seconds is up, we will hard code some values, and then we will return the data. Okay, so once we have this function set up, we will want to go to views.py and modify our post request. So as you can see, we've moved this logic out into tasks.py so we can delete it from here. And also for now, we will also delete the logic to save the data to the database. So we will basically call that function here. We'll call the scraping task function in this post request, and we'll call it .delay and passing in the two parameters. This is how you call a salary task, and we need to import scraping underscore task. So from import scraping task. After the task is passed to the queue, the return will be a task ID, and this task ID is type async result. So if we want to see the actual task ID, then what we can do is we can cast it as a string so that when the response gets back, we will see result and then the task ID of the task that we just created. And maybe we can change this to 200, okay. So now that we have the code ready, what we can do is we can first start the RabbitMQ, and then we can start our API service. So once the RabbitMQ startup completes, we first need to migrate our database. So we need to run python manage.py make migrations, python manage.py migrate, and that's gonna update our database. And then from here we can run python manage.py run server, and that's gonna run our server. So once this is running, we can go to the web browser and go to localhost 8000/API/scraper. And you will see that we get a HTTP 200 OK request, and there's nothing in it currently because the database is empty. If we hit post, it returns back a result with its task ID. So now if you go to RabbitHost UI and type in the default password, which is guest, username and password is going to be guest, and if you log in, then you'll notice that there's a single queue, there is a single task that is ready to be consumed. And right now this task is in the queue. However, it is not getting consumed since we haven't started our Celery worker yet. And that's what we're about to do next. To start our Celery worker, what we can do is we can open up another terminal and run this command here. Celery-a space the project name, which for me is called core, and then space worker space -- log level equals the info. And the reason that this is not working is because I need to source the environment. And then I can try to run this again. Hopefully there's no errors. Okay, and as you can see, now it's scraping in process. It's consuming the queue, taking 5 seconds. Then it says scraping is done. So we successfully consumed that queue. If we go back to our RabbitMQ UI again, you'll notice that the ready value is 0 since now we consumed that queue. And if you go to the API endpoint and then you refresh the page, we notice that there's still nothing in our database. And the reason for that is because we haven't triggered any function to store the data into our database yet. So we need to do that first. So right now we just basically pushed the task onto a queue, and then Celery consumer consumes the queue, and that's it. And so let's go back to our tasks.py file. First thing we need to do is we need to import the necessary libraries, such as post serializer, because we're going to be using that to store our data. And then we're also going to import task_success from celery.signal to basically trigger the signal when this scraping task is finished. And we're going to create a function called save to db_task. And then we'll use the decorator task_success.connect. And then the sender for this signal is going to be coming from scraping_task, which is the function name that we created here. From there, we'll do some debugging print statements to make sure that we reached this function. And from there, we can get the results by typing keyword-args.getResult. And the reason we can do this is because we set up a backend for our Celery. So the results are stored in the database. And when we call this get function, it basically gets the data that we processed here from the database. And now, once you have that data, you can either make a request to call to a different endpoint that saves the data, or, which is what I'm doing right now, which is I'm going to store the data right here. So I'm going to iterate over the post and serialize it. If it's valid, then I'm going to save it. And after that, I'll print save data success. So since we made changes to our tasks.py, in order for the Celery worker to recognize this new function, what we have to do is we need to restart our Celery worker. So we need to kill the Celery worker and then restart it so that the new function that we created, it's going to get registered. If you know module named celery.signal, I think celery.signals. Yeah, that should be it. There we go. Once Celery is ready, the workers is ready, then what we can do is we can go back. Let's make sure our server is still running. Yep, our server is still running. So let's go back to our API endpoint. And in this case, if we get, again, see there's nothing. So if we do a post, returns back the ID. And then if you go back, you'll notice that scraping process, scraping done. Once it's done, then the save to DB task is getting triggered. And it's going to print out reach store to DB and then save data success. So now if we do get again, then you'll notice that the data that we hard-coded in the code is here. So now that our application works locally, we can containerize this application. And first thing we need to do to create a Docker file. First, we'll use Python 3.10, set some environment variables, and create a working directory. Then we'll add the current directory to the container, and then making sure that pip is upgraded, and also install all the necessary requirements.txt, and expose port 8000, and also set an environment variable called is_prod and set that equal to true. And then we'll copy a file called entry point from our current directory to our container directory. And then we'll run a sed command to get rid of all the /r, which I believe is tabs in our file. And then we will make sure that the entry point.shell is executable. And then from there, we'll execute the entry point.shell file. Next, we'll create the entry point.shell file. Create a new file in the root directory called entry point.shell. So first, we want to set up our database by running the migration commands. And then we want to run the collect static. It's basically collecting all the static file into one place. And then we want to start our Celery worker that will consume the queue. And something to notice here is that you want to make sure this name here, this name core, is your project name. In my case, I named my project to be core, therefore I will have this. And then also you'll notice that I am getting the result of the output into a log file called celery.log. Therefore, we can have access to the output of the worker if we want to debug any issues. Then next, you want to run the gunicorn command that would set up our web server. And one thing to know is that you want to make sure same thing again. This right here is your project name. In our case, it's called core. Since we have the collect static command, that means we need to make sure that we have a static root directory in our settings file. So you want to head over to your settings.py and set the location of your static root. And in this case, you want to import OS. One more thing that we want to make sure that our Docker container is set up correctly is to make sure that we run pip freeze one last time to make sure that we have all the necessary requirements. Again, I need to source the environment. Now that the Docker container is set up, the next thing that we want to do is set up docker-compose file. So you want to create another file called dockercompose.yml. We'll start by stating the version, which is 3.8, and then we will start declaring the service names. First service is going to be called API, and that's going to represent our Django API endpoints. And the build context is going to be just // that's just representing the current Docker container, for our Django app. And we want to make sure our ports are open, are exposed. So we'll set the ports, and we want to make sure that this API is going to start after RabbitMQ has started. So therefore, we want to make sure that the API is going to start once the RabbitMQ server condition is healthy. And to do that, you will just use depends on. And next, we'll declare another service name called RabbitMQ. And in here, we want to download this image here. The latest image right now is 3.13-management. And the reason I'm using -management is just for debugging purposes, so that you can have a UI for your RabbitMQ server. If you remove this -management, then you wouldn't have a UI with it. Then the image wouldn't have a UI. Then you want to set your ports, set the volume, the environment, and also have a health check. So this is going to basically make sure that your server is up and running correctly. And depending on this health check, your API is going to build. And lastly, you want to mount that volume like this. So now we have Docker Compose set up. We can run the Docker Compose commands. But before we do that, let's make sure that we shut everything down. Making sure that your RabbitMQ server is down so that we wouldn't get the address being used here. And also let's shut down our worker as well. So once everything is shut down, then you can run Docker Compose build. And this is going to build the image. Once your image is done building, then you can run the command docker compose up. And you'll notice that your service is starting to build. And in this case, the build is a little slow since we're waiting for RabbitMQ to build first, and then our API service will build next. Okay, as you can see, the RabbitMQ finished building, and then the API started to build. And we got an error, app static entry point gunicorn not found. Okay, so we forgot to pip install gunicorn, so we need to do that. So I'm gonna kill this, pip install gunicorn, and then make sure you do a pip freeze. Okay, so now we have to rebuild it again. Let's try that again. So I finished building. Now we're going to run the Docker Compose up one more time. So this time it has no issues. So let's go over to our browser one more time. Hit refresh, and this time, if you want, you can hit post. And in this case, you'll realize that your API is actually airing out connection refused. Okay, so what's happening here is that we're not connecting to the RabbitMQ correctly. And the reason for that is because right now we are running RabbitMQ in Docker Compose. Within Docker Compose, the Docker container is going to create its own network, and we can no longer refer to local, we can no longer refer RabbitMQ using localhost. According to the Docker documentation, in order to refer a service that's within the Docker, if the service wants to talk to each other, then they will then their host name will be the service name. In this case, if within my API service, which is my Django REST API, where I set up the Celery, application, if it wants to connect to RabbitMQ service, then we need to use the host name RabbitMQ instead of localhost. And if you go to settings.py, you'll notice that we have Celery broker _URL here is trying to connect to the localhost rather than the RabbitMQ. So we need to change this to RabbitMQ. And remember, this host name is just going to be the service name according to the Docker documentation. And I can link that documentation in the description. And something else that we can do here is we can import OS, and then we'll get the isProd variable from os.getInv, and we'll get the isProd environment variable, and we'll set this to false by default, and then we will check whether if this is prod. If prod is equal to true, then we will use the RabbitMQ hostname. If it is false, then we will use the localhost hostname. There is another error. It's get. I have made a typo here, so I need to rebuild and rerun it again. Okay, now I'm going to do the Docker Compose up again. Okay, so this time I think there is no more issues. So now that our services are up, let's go back, refresh this page, and let's see what happens. Okay, so it's still, let's see. Okay, so it's still hanging up. Connection refused. Okay, so I figured out my bug, and turns out in my init.py file, I forgot to save this. It just kept on showing connection refused. So, yep. And once I saved this file, now I closed it. I closed everything, files, everything saved. Now it's working. So if I reload this, if I hit post, it's going to be the result. And then if you wait for 5 seconds, then you should be able to see new results. And then this is number 8. Now if I just do it again, wait for 5 seconds, it's 8. There you go, number 9 and 10. Yep, now it's working. Well, that's it. Thank you for watching, and see you guys next time.